So in this question, you are going to calculate the molar mass of an acid. So based on the information provided, we are going to calculate the molar mass of the acid. First of all, we need to highlight the important things, right? So we have 5.92 grams of tribasic acid. Tribasic acid means the acid can ionize 3 hydrogen ions. Okay, so, and when we dissolve it into water and made up to 250 cm cube. So in your brain and in your mind, you should know that we will use an 250 cm cube for volumetric fast. And afterwards, we will withdraw 25 cm cube of the solution using a 25 cm cube pipette and transfer it into clinical fast and do the titration. And the burette will put the sodium hydroxide in it. So that's the information the question provide to you. So based on the information, we are going to calculate the molar mass. Come on. Yes, first of all, in your mind, you should have such diagram. So we have 25 cm cube. Okay, tribasic acid. So we going to calculate the molar mass. First of all, we need to calculate the number of mole of the acid, and we have the mole and have the mass, and we can calculate the molar mass, right? So in the burette, we will put sodium hydroxide in it. So first of all, in this question, or for this kind of question, you need to write down the chemical equation first. So we use the tribasic acid to react with sodium hydroxide, right? Since it is a tribasic acid, it will the mole ratio between sodium hydroxide and the tribasic acid will be 1 to 3. And we will form sodium 3x and also water, right? So what you need to do is balance the equation. So how can we balance such equation? First of all, since we use 3 and should be 3 in that side too. So the mole ratio between the acid and the sodium hydroxide will be 1 to 3, right? And first of all, what you need to do is calculate the number of of the alkali used. So we have the volume and we have the concentration. So most of sodium hydroxide reacted will be 0.5 times 18.5 divided by 1000. And you will get the number of mole, right? Because volume times the molarity, and we will get the number of mole. And you will get 9.25 times 10 to the power of negative 3. So that is the number of mole of sodium hydroxide reacted. And then inside, it means that we use this number of mole of sodium hydroxide to react with the tribasic acid in 25 cm cube. So in 25 cm cube, the number of the moles of the tribasic acid will be, since the 1 to 3 ratio. So the number of mole of H3X inside 25 cm cube will be 9.25 times 10 to the power of negative 3 divided by 3. Okay. And you will get 3.08 times 10 to the power of negative 3. So you will get the number of mole of the acid inside 25 cm cube. So how about in 250 cm cube? The number of mole of the acid in 5.92 gram will be equal to the number of mole of the acid inside 250 50 cm cube, right? So in 255 cm cube, the moles of H3X will be 3.08 times 10 to the power negative 3 times 10. Okay, so you should be able to know why we need times 10 over there. So you will get 0.0308 as the result, as the number of mole of acid inside 250 cm cube. So when we chase backwards, the number of mole of the acid in 5.82 gram will be also in 5.82 gram. Okay, tri-basic acid. Okay, it will be also equals to, we will have 0.0308 mole, right? And finally, we have what we have is the mass and also the number of mole. So you're going to calculate the molar mass of the acid, right? Finally, and the molar mass will be the mass divided by the mole. That's the concept in the previous chapter. And finally, you will get 5.92 divided by 0.0308, and you will get 192.2 gram per mole. It means that the molar mass of the acid will be 192.2 gram per mole. So that's how we can, based on the information, to calculate the molar mass of the acid.